Okay, so we have been learning how to factor. Okay, we started off with a basic trinomial that looks something like this. X squared plus 4x minus 12. Now, you don't have to write this anywhere. It's not in your packet. You're just paying attention. Okay, then we moved in to something that looked like this. 6x squared plus 66x plus 60. Okay, so they're both trinomials. They're both in the form ax squared plus bx plus c. What's different about them? Guys, what's different about these trinomials? Well, yes, the signs are different. But the main thing that I'm wanting you to notice is, look, right, this one has a 1 in the a place. This one has a 6. So this one, since it has a 1 in its a, you can go ahead and bubble method it right away. And the way we do the bubble method is we have to put an x at the beginning of each binomial to produce that x squared when we FOIL it. And then to get the numbers that go in the binomial, you just have to remember that they add up to positive 4 and they multiply to negative 12. Well, if you want to multiply two numbers and it be a negative answer, what kind of numbers do they have to be? Like, what do their signs have to be? 1 negative, 1 positive. Or you could have put 1 positive, 1 negative. It doesn't matter where they go. But to get a negative number when multiplying, you have to have 1 negative sign and 1 positive sign. Now, what are some factors of 12? 3 and 4. What else? 12 and 1. 6 and 2. Out of those three sets, which one do you think you could possibly get a 4 from? 6 and 2. Okay, so is it going to be negative 6 plus 2 or negative 2 plus 6? Right. Negative 2 plus 6 is positive 4. Negative 2 times 6 is negative 12. So that's how you factor a trinomial that has a 1 in the a place. Now over here in the a place, we don't have a 1. We have a 6. So you can't just go straight to the bubble method. What do you have to do first? Pull out the GCF, which is 6. Then inside parentheses, you write the remaining trinomial. 6 divided by 6 is 1. So all that's left here is 1x squared, and you don't have to write the 1. Bring down the plus sign. 66 divided by 6 is 11, and then don't forget the x. Plus 60 divided by 6 is 10. Now that we've pulled out the 6, doesn't our remaining trinomial look just like this one? Its a value is 1. So we're ready to bubble method it. Now, you have to bring down the 6. If you leave off this 6, your answer is incorrect. 6 is part of the answer, and we'll talk about why in a minute. Now we're ready to bubble method by looking for two numbers that add up to 11 and multiply to 10. Positive 10 and positive 1. Now, let's talk about why the whole answer would be wrong if you left off this 6. If you told me that this was the answer, I would say there's no way it's the answer. Because if I FOIL that, x times x is x squared. X times 1 is 1x. 10 times x is 10x, totals up to 11. 10 times 1 is 10. Does that look anything like the question? No, but had this 6 been out there, would it now distribute to that and make it 6x squared, and that would become 66x, and that would become 60? So that's why the 6 has to be in the answer. Okay, now the next thing that we learned was factoring these type of binomials. Do you remember what the first one's called? It is a binomial. A difference of 2 squares. Difference because it's subtracting. 2 squares because each of these are perfect squares. What does it mean to be a perfect square? Like, why is 36 a perfect square? Right. A perfect square is a number obtained by multiplying a number by itself. So x squared is also a perfect square because you can do x times itself to get x squared. This is called a sum of 2 squares. Now, Isn't x squared minus 25 just basically x squared plus 0x minus 25? I mean, think about it. In the middle missing, we have an x squared and we have a constant. We're missing the x to the first term. Well, if it's missing, don't you think that's because it was 0? So if you think about this the way we've been factoring, you're just adding to get 0, multiplying to get negative 25. Now, these are called special cases, and they're actually easier because what did we learn yesterday about these? When you're factoring a difference of two squares, what makes it so easy? What? Somebody said it. Right. They both have an x, and they both have the same number. And to get a 25, they both need to be 5. What's the only difference in the two binomials? And why is that necessary? And so they'll cancel each other out, leaving no middle term. Okay, so now over here, remember we learned that they look almost the same, x plus 5 and x minus 5. However, obviously this cannot work for this and this. Okay? Because if we FOIL this, it would be x squared minus 5x plus 5x, which would cancel, and then minus 25. How can we turn that into a plus 25? The i's. Remember, if you attach an I to both 5's, let's see what happens. X times x is x squared. X times negative 5i is negative 5xi. 5i times x is positive 5xi. And 5i times negative 5i is negative 25i squared. Okay, the middles cancel each other out like we wanted because the middle up here is missing. But then, what's I squared equal? And what's negative 1 times negative 25? Which is what we wanted because that's what the question is. So do you see why with the difference of two squares, you just write it like this, but with a sum, they have to have complex numbers? Okay, so now let's start with page 8. Okay, today we're going to be factoring trinomials, but you know how normally the trinomials are like x squared plus x to the first, and then the last term never has an x at all? Well, today, look, all of them have x's. So, when we factor out a GCF, the GCF is no longer just going to be a number, it's also going to be a letter. Now, the easiest way for me to tell you to do this is pull out the smallest number and the smallest variable. So I got a 2, 6, and 8. What's the smallest? 2. Out of x cubed, x squared, and x to the first, what's the smallest? X. So 2x is your GCF. Now let's talk about how to figure out what's left of that trinomial. Well, 2 divided by 2 is 1, but you don't really have to write a 1. Now, this term had x cubed, which is 3 x's, correct? But if we took out 1 out of the whole problem, doesn't that just leave 2 of them? Okay, see how we pulled out an x? When you do that, you're pulling an x from this term, and this term. So it started off as x cubed, but since we factored out one of the x's, it leaves it as x squared. Okay, bring down the plus sign. What's 6 divided by 2? 3. But it was x squared, but we factored out one of those two x's, so how many are left? Right. And then bring down the minus. 8 divided by 2 is 4. And look, the only x it had was factored out, so there's no more x's over here. And the reason we do that is because, look, now we have a trinomial with an a value of 1 that we can factor using the bubble method. Okay, so we're adding to get 3, multiplying to get negative 4. If you're multiplying to get a negative, what kind of signs do you have to have? Right? And what numbers would multiply to 4 and add to 3?
4 and 1.
What's what though?
Positive 4 and negative 1.
Right. And that's the final answer. That whole thing is the final answer.
Yeah.
Okay? Alright, now let's look at the next example. What would the GCF be for this example? 2x cubed. Because 2 is the smallest number, and x cubed is the smallest variable. So we factor it out. Now let's talk about what's left. 2 divided by 2 is 1. but you don't have to write the 1. If you add x to the 5th, but we factored out 3 of them, how many are left? Right? Then we just bring down the minus. 4 divided by 2 is 2. But there were 4 x's. We pulled out 3, so now there's only 1 left with that term. And then minus 6 divided by 2 is 3. And if it's 3 x's, all of them were factored out. So there's no more x's left over there. And that's a good thing, because now doesn't this look like a trinomial that we can bubble method? Okay, since we're multiplying to get a -3, what does that let you know about your signs? 1 positive, 1 negative. You have to have opposite signs to be able to multiply and get a negative. And then what are the only 2 numbers that multiply to 3? Right, because it's prime. And so how would you arrange that so when you add the 3 and 1, it'll be a -2? If you do positive 3 and -1, that would make a positive 2. Right. Oh, this is a mistake. I meant to write cube. Oh, because your x cubed is your smallest variable of the 3. You have x to the 5th, x to the 4th, x to the 3rd. You pull out the smallest one. And this was just a typo. I meant to put 3. Okay, so to get a -2, if you're looking at 3 and 1, which number's bigger, 3 or 1? 3. And if you want it to stay negative, you put your bigger number with the negative. If you wanted it to stay positive, you would have put your bigger number on the positive one. Okay, now let's look at the next one. Okay, this is an understood 1. So what's the smallest number? 1. But do we really have to write that? No. What's the smallest variable? X. So that's our GCF. Now, this had x cubed, but we factored out one of those x's, so how many are left? X squared. And then bring down the minus. Right, all that's left is 4 because you took out the x. Now, what do we have here in parentheses? What is that called inside the parentheses? We literally just talked about it 3 minutes ago. A difference of 2 squares. And what's special about a difference of 2 squares when you factor it? They look the same except for their sign. Okay, to get x squared, you would do x times x. To get 4, you would do 2 times 2. But one of the 2's had to be negative, so that it would be a -4. Any questions so far? Okay, the 4th example gets a little bit trickier. For that reason, we're going to forget about the signs until the very end of the problem. Okay, so we're just going to leave blanks where all the signs would be. Alright, first of all, what would the GCF be? 3x cubed. Because 3 is the smallest number, the smallest coefficient, and x cubed is the smallest variable. Now let's talk about what's left. 3 divided by 3 is 1. Okay, x to the 5th, if x cubed has been factored out, that leaves x squared, right? 15 divided by 3 is 5. And it was x to the 4th, but 3 of those 4 have been taken out, leaving only x. And then 18 divided by 3 is 6, and it had x cubed, but all of them were factored out. So there's no x's on the 6, no variables. So it's now a constant. Alright, now, have you ever tried to factor a trinomial that started out as -x squared? No, they always start positive, right? You can do it when it's negative, but it's a little more complicated, so we're not gonna leave the negative in there, because why would we want to make it more complicated? So we're going to factor the negative out as well. Now, all that happens when you factor out the negative is every other sign changes. See how the original trinomial was negative, negative, positive? So we're going to do the opposite. Positive, positive, negative. Okay, let me say that again. We don't want our x squared to be negative, so we're going to factor it out. And when you do that, every sign will change. This negative becomes a positive, but you don't have to write a positive right there. This negative became a positive, this positive became a negative. Now let me show you why that has to be. Like if you were to quickly distribute this back out, isn't a negative 3 times a positive 1 a negative 3? And a negative 3 times a positive 5 is a negative 15. A negative 3 times a negative 6 is a positive 18. That's only when your leading term is negative that you have to worry about that. See how the sign in the front is negative? That's the only time you have to worry about factoring out the negative. Now we see that we are left with a trinomial that we can use the bubble method on. So we're looking for two numbers that add up to 5 and multiply to negative 6. What do your signs need to be if you're multiplying to get a negative? Right? Okay, what are some factors? 6 and 1, 2 and 3. What do we have to use though? 6 and 1, because since one of them is negative, the 2 and 3 won't work. Because you would need both of those to be positive to make a 5, right? But you could do a positive 6 minus 1 and get a 5. And then when you multiply them, you can get a negative 6. Okay, why don't you try number 1 by yourself, and then once you've had time, we'll go over it. Okay, for number 1 down here, what is the GCF? 4x. Does everybody understand how I'm getting that? Okay, now, to leave what's left, you're basically dividing. 4 divided by 4 is 1, but you don't have to write it. If you had x cubed, and you took out x to the first, you're left with x to the second. Also, have y'all ever divided variables? You know how when you multiply variables, like x cubed times x squared, what do you do with those exponents? Add them, and you get x to the fifth. When dividing variables, what do you think you do to the exponent? Subtract x to the first, because 3 minus 2 is 1. So like when you divide x cubed over x to the first, that's why you're left with x to the second, because 3 minus 1 is 2. And then bring down the minus. 28 divided by 4 is 7. X squared divided by x to the first is x to the first, because 2 minus 1 is 1. And then plus 24 divided by 4 is 6, and x divided by x is 1. And so 6 times 1 is still 6. Now we have a trinomial that we can factor using the bubble method. Okay, what are the numbers that are going to multiply to a positive 6 but add to a negative 7? Right. Okay, go ahead and try number 2. Alright, what is the GCF for number 2? Negative 4x, because since there was a negative on the leading coefficient, you pull it out. Okay, what did that leave? Minus 72, right. Because remember, every sign changes. It was negative, negative, positive, so now it's positive, positive, negative. Okay, now we continue bringing down the GCF, and we factor. They have to add up to 1 and multiply to negative 72. What numbers will do that? Right. 9 minus 8 is 1. 9 times negative 8 is negative 72. Okay, go ahead and try number 3. Alright, what's the GCF? Okay, what does that leave? Okay, then we can factor that into what and what? Right, because they add up to negative 5 multiplied to positive 4. Okay, what's the GCF for number 4? X. What does that leave inside parentheses? Okay, what is that called? Difference of two squares. And what makes factoring those easy? They're the same exact thing except for their signs. So x, and what numbers would make 25? Right. Okay, now turn to the next page. Okay, the next page is a lot of problems, so this is what I suggest. They don't have to be done until next Friday because that's when the 10 square is. However, I would do 5 today or tonight while they're fresh on your mind, and then maybe do the other 5 this weekend to refresh your memory for the quiz that'll be Tuesday. Because if you do all this today and never look at it again, I think you're going to go blank on the quiz. So I would save some of them for over the weekend or either Monday night so that you'll know how to do it on the quiz. Got it? Okay.